Hi everyone, my name is Risha. Today is the 6th of August 2025 and I'll be going over my first Algo sort of computer science massive project, which is a head and shoulders pattern identification algorithm. So before we get into this video, what is the head and shoulders pattern? And I have the pattern sort of on the right here so you can see basically what it looks like. It's a classical technical analysis formation used to identify trend reversals in financial markets. And it consists of three peaks. So the left shoulder, then the head, and then the right shoulder. And the neckline here doesn't have to be slanted, it can be a straight line. It's just a trend line connecting the low points between the shoulders and the head. And when broken, this confirms the pattern. So the head has been between the left and the right shoulder and is always higher than the two. And this pattern is a bearish signal since it signals the end of an uptrend and used to identify short selling opportunities. Now, so what have I done here with this project? So I've tried to automatically detect head and shoulders patterns from stock price data and simulate trades based on them to evaluate their profitability. But mainly the main focus is just to identify these patterns in price data. So the script first loads and transforms stock price data in log transforms it specifically. Then it finds local maxima and minima using rolling windows. That's not a module, that's just another file I've coded. Then it scans price, however much price data you give it for the head and shoulders pattern structure. And it confirms the pattern but by neckline break. So it can simulate, as in there is a testing function at the end that can simulate entry, take, profit, and stop losses, and can track portfolio returns. The modules used for this project are, of course, Pandas for data handling, NumPy for numerical operations, Y-Finance or Yahoo Finance, that's the Yahoo Finance API, for downloading stock data, Matplotlib and MPL Finance for visualization options. Now this is optional. I have the function coded, but I haven't called it in the main function. You will see this because it was more about the identification than the sort of plotting that price action. Then Deck from collections, which is efficient rolling storage, data class module to store pattern attributes, and typing for type hinting. And then rolling window is just a module that I coded for to identify tops and bottoms. Now, if we go here to this GitHub page, which is public, keep this in mind, I have everything I'm going to say here is pretty much on this README, so feel free to look through it. But if we go here into the actual code of the head and shoulders Python file, we can see these are all the modules I just mentioned. So let's go through this code, right? So first we sort of declare the class head and shoulders pattern. These are just the initializations. So for the head and shoulders patterns, these are sort of all the important numerical values you want. So the left shoulder, the right shoulder, the armpit is between between two peaks. So I'll go back here. So this would be an armpit here in this case. Then the left and right of those. Then you want the head. You want the left shoulder price. So this would be, So this would be the price at which the left shoulder occurred, the price at which the right shoulder occurred, the price at which the armpits, and the price at which the head occurred. Then we would have the start date, in this case it would be a date time attribute. And then we have some other custom attributes which we will use for calculations like R squared. So neck slope, head width, head height, pattern R squared. So these are mainly to check that the head and shoulders pattern is valid. There are certain rules. Keep in mind this is a computer, so you do have to give it some rules to identify the head and shoulders patterns. When we get to that function, I will cover that. Now these are a little out of order, but to compute the first sort of function, I guess, the very main one would be this one at the bottom. But before that, we had to code all of these kind of four major functions. So the first one is to compute the pattern R squared. So once we have identified a pattern, we can input it into this function, which one of the inputs is the HS pattern sort of class object. So what this does is it calculates the R squared, which is also called the coefficient of determination. All this is just saying how close to an ideal head and shoulders pattern is the one that we identified. So these are just some calculations I will go through. So if we go back to this slide here, you can see that there's the head and shoulders, it's a bunch of lines, right? So line here, line here, line here, line here, line here, line here. What this does is it calculates the slope and the y to the line formula. So y equals mx plus b or mx plus c, puts it in that sort of format, right? Calculates the line equation. So here you go. This is the same thing here. So line slope, line 0, line 1, line 2, line 3, line 4, line 5. So this corresponds to sort of 1, 2, 3, 4, 5, and then this one here, we'll get to this one. This one's important. This is the confirmation. Right. So the raw data, so what this sort of function does, all right, it calculates the mean, calculates, this is just data processing, to be honest. The real important stuff is here. So SSRes stands for the residual of the pattern, right? The sum of squared residuals, and this is the total residual. So what this does is it says the variance of the product of the sort of inputted head and shoulders pattern object, the object being an instance of this class above, how different it is to these sort of the ideal head and shoulders pattern. And this is just the total variance of the ideal head and shoulders pattern itself and the data we provide. So the R squared formula is 1 minus the sum of squared residuals over the total residuals. So as you can see, this is what we've done here, and then it calculates the R squared, gives us the fit to the ideal head and shoulders. Now, before we cover this one, let's first go through this. So find head and shoulders patterns. So the inputs it takes are, first of all, data. You need a NumPy array for that. You need the order, and I'll cover what that is. The early find, so this is a sort of a custom variable. So you can do an early find, in which case it confirms it before the break. So I've set this in default to false because, yeah, sure, you'll get more identifications, but they're more likely to be wrong. But if you keep this as false, then the pattern has to be confirmed for it to be flagged in this program. So what this basically does, all right, let me go through the code. These are just initializations. We'll get to why they're important, right? So the hslock is just a variable which makes sure that we don't repeat the same. So if we don't find the same pattern twice, it's just a sort of arbitrary true or false Boolean to make sure we don't count the same thing twice. So if we go here, so the RW, this is rolling window, this is just a custom module. All it does is it finds the recent highs and tops in a rolling window. That's literally all it does. So if there is a rolling top, then it adds this to the recent extrema. So here, the recent extrema, they can be up to 5, and recent types, so a -1. So if the recent extrema is a bottom, you will get inputted a -1. And if it's a top, you'll input a 1, right? So if it's a top, you append a 1 to recent types. And then if it's a bottom, you append a -1 to recent types. You set the hslock false, and the last is top to false, because it was a bottom. And if it's a top at the end, then you set the last is top to true. And as long as there's less than 5, less than 5 recent extrema, we continue to. We need 5 of the most recent extrema, right? So if the last is the top, what we want to do is we want to set HS alternating. So if they're not alternating, you want to set it to false, right? And basically all this does is, so what this does is it goes through the data, it sorts it out, finds the recent extrema, because you keep in mind how the HS pattern looks is you need these recent extrema, 1, 2, 3, 4, 5, right? We need this to be able to confirm that there is a head and shoulders pattern. So once we have the 5 most recent extrema, all this does is puts this data into the check HS pattern, and it returns true or false, right? So now let's go up to check HS pattern. Now this is the most important function, right? So what this does here is, all right, this does a bunch of checks, right? So I've annotated it here so you guys can see as well. So first it finds the right shoulder and max price as the max price since the recent right armpit, right? So calculates the right shoulder. And then what it does, now we get to the checks, right? So we already have the HS pattern object, which we're going to input into this function. So the first check is that the head must be higher than the shoulders. This is a very important one. You can see clearly the head has to be higher than both the shoulders, otherwise it's not a valid pattern. That's what this little part here does. So you want to also make sure that the shoulder's midpoint is the midpoint between the shoulder and the armpit. So what this means is, between this and this, you want to make sure that there's not too much of a difference, right? That's basically what this part here does. Sorry, let me go over to Google. Yeah, here you go. Now the symmetry rule. What this part here does is make sure that the difference at the time, as in these can't be so long. There has to be a certain amount of width between the two shoulders. We're just trying to make sure that it's not too slanted, and it needs to be around a similar sort of time, right? And again, these are all values that I've optimized, so feel free, if you want to change these, you can go ahead. So the symmetry rule is where I've put 2.75. You can again change this value if you want. So we are saying that if the right to head time, so right to head time, is greater than 2.75 times this to this time, then it's not a good pattern, right? It's not a valid pattern. So it has to be within that sort of, and this is lenient. So you can reduce this to be stricter. You can make this 2, right? And you will get less identifications, but you will be more accurate, right? Now the last part of this is to compute the neckline. So you see that this is a slanted neckline. It doesn't have to be, but you can. So then we calculate the slope of the neckline's line, could be anything. And then it calculates the neckline value at the current. So you see that this is a line, right? If this is a slanted line, we need to know when it is broken, right? So if it has been broken, that's how we will confirm the pattern, right? See, and there we go. We confirm the pattern when price is halfway from the right shoulder. So once this right shoulder is formed and it's sort of around here, that's when we confirm it. We confirm it with the neckline, right? That's what it is. Find the beginning of the pattern. Again, this is just finding the time. So this is when the final return output comes out, it'll give us the date at which the pattern started. That's all it is, right? And now what it does is, now that the pattern is confirmed, we're putting in all the values we calculated to create a consolidated HS pattern class object. So once we have this, this is the testing module. These are the 2 I was talking about, right? So this is going to give you all of your, to see if it's a successful pattern or not. If we go down to this test pattern, this is going to give us even more detail. Gives us the overall return, and it returns the final capital, as in the after like we started off with 100,000 notional. You can see here 100,000 initial capital gives us the final capital from which you can calculate the return, win rate, average loss, average wins. All of these are calculated in this function, right? You can see the calculations here. And now we get into the main function, right? All this function does is it calls on all the functions we have. So a lot of these are recursive in the sense that we set up the data, pull the data from Yahoo Finance, log transform it so it's more normalized. Otherwise, price data is too erratic. It's going to be very difficult to calculate R squared, for example, right? And now what this main function does is it outputs the dates at which the head and shoulders pattern appeared in the last 10 years. This is just because I've gotten 10 years of data. You can do 5 years, 5 days, which is very unlikely you're going to find any head and shoulders in 5 days. You can set your period. So this is by default daily data for the last 10 years. You can change this, right? So this is where Yahoo Finance is good. It's very flexible. And if there's none, it will print out no head and shoulders found. Then what it does is, here you go, you get from this test pattern module we just talked about, it'll calculate all the performance metrics and output them out. So yeah, this was just a very, very quick and it was a good overview of what this project is. It's an algorithm which identifies head and shoulders patterns. And yeah, that's all for this video. Thank you for watching. Enjoy, and I'll see you next time.